Welcome back to Pure Science Education. We will be looking at A-level electronic configuration, followed by the video if you previously watched GCSE electronic configuration. If you didn't get around to watch that, we will have a quick summary. So as you can see here, with sodium atom. Sodium has got 11 electrons and it's got electronic configuration of 281. It has got 3 filled energy levels, which are shells, and if you look at each one, it's got 1, 2 and 3, and where another quick whiz through is here. In the middle you got the nucleus that has got protons plus neutrons. Here you got your electrons on the shells, and what we're gonna do, so look at how this electronic configuration is written at A level. So far a really quick whiz through for the GCSE, and I'll go through this one more time in terms of where you get the 281. So if you was to look at the GCSE, the rule is the electronic configuration from hydrogen to calcium is all you need to know, and the rule is 2882 rule, which is 2 electrons in the first shell, 8 in the second, 8 in the third, and 2 in the final shell, which adds up to 20, which works for calcium. So this shows the Bohr model, and now if I was to translate the 2882 rule into A level, it does not look the same. So let's have a look at that now. So if you can see, there is a periodic table in front of you. I'm going to introduce some new terminologies in a minute. Before I do that, I wanted to just quickly tell you how the periodic table works. So if I was to highlight these two groups here, 1 and 2, they are called S. If I was to then highlight your transition metals over here, they are called your D. Then we go back here, this is your P, and then finally on the bottom, this bit here, is called your F. So your transition metals are D, group 1 and 2 is S, 3 to 8 is P, and then the bottom one is called F. So what does these letters mean to you? So what we're going to do is look at your SPDF. So if I had a element that had 4 energy levels, 1, 2, 3 and 4, I'm going to say N is equal to 1, 2, 3 and 4. I can then divide these 4 into sub shells. These sub shells are your S, P, D and F, and we're going to leave F out of the picture for today because it's slightly complicated. S is the spherical shape elements, P has dumbbell shapes, D and F have variable shapes. These SPDF, S has 1, P has 3 shapes, D has got 5, and the F has various shapes. So all of these has those shapes, and the orbital, in each orbit it can hold maximum of 2 electrons. So that's the key. So what we're going to do is look at how many electrons does SPDF hold. So if I was to look at S, 1 times 2 gives me 2 electrons. P, 3 times 2 gives me 6 electrons. And D, 5 times 2 gives me 10 electrons. So this here, this here is quite important that we understand. If it's anything in s orbital, you can only have maximum of 2. If it's p, maximum of 6. D, maximum of 10. So let's look at what does that mean to you. If I was to write these out, 1 sub shell is 1s, 2 sub shell is 2s and 2p, 3 sub shell is 3s, 3p and 3d, and 4 sub shell is 4s, 4p, 4d and 4f. We're going to leave the f out of the picture. So now in terms of your A-level exams, how does that work? So if you was to write electronic configuration, for sodium, as we know, sodium has 11 electrons. At GCSE, you would have said 281. And having a look at that, this A-level will become 1s2, the first shell. Second is 2s2, 2p6, and 3s1. So let's have a look at how do I get to this electronic configuration. So if I was to draw my 1s, I have got a bust eating rule. In my bus I can put one person, which is these are your electrons, and then the second one, and these are repelling, hence you draw them the opposite way because they spin. Now bust eating rule is about if you can have lots of different rows, but you fill in one row at a time and then you come back and fill in the next row. So for 2s, I have to do the same. I'll fill in the one row and then the next. So here 1s, and then because it's got 2 electrons, I put 2. 2s, I have 2 electrons, I put a 2. Now if I look at 2p, I have got 6 possible electrons I can put in. So because these 2 seats are full, I'll go to next one and next one and next, but because I still have spaces, I can go and fill in my seconds, and that becomes 2p6. And if you look at 3s, I only have 1 electron. So if you was to then look at the trend and match up to GCSE, so you go 1s2, you've got 2s2, 2p6, and then you have got 3s1. So if you look at this, it becomes 2, 8 and 1, which still quite follows your GCSE scenario. So let's look at a different example. This time we're going to look at magnesium. Magnesium has 12 electrons, and at GCSE you would have written 282. In A level you will write 1s2, 2s2, 2p6, 3s2. Now you need to be really careful if you're looking at atoms or ions. So if I was to write electronic configuration for a magnesium ion where I've lost 2 electrons, then it will become 1s2, 2s2, 2p6, which means I'll lose my final shell. There are exceptions to this, and the two exceptions are chromium and copper. So let's look at the exceptions. So if you was to look at chromium, you would expect it to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But instead, I get 4s1 and 3d5. The reason being, if I look at my 4s, I have my 2 electrons. If you look at my 3d, 1, 3, 4, 5, I have my electrons here, and this electron gets promoted there, and you end up with a totally different configuration because of the energy level. The other exception we have is copper. Copper should be 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2, 3d9. Again, I end up getting 4s1 and 3d10 because, again, just like the above example, I promote my electron that then gets moved into a d electron. I hope this has helped. It's quite a rather complex topic when you go from a GCSE to A level, so please revisit the GCSE video and then follow it up with this A level video. Thank you.